Hi, this is redoing this rate law problem. It was rate law problem 2, and just goes to show you anybody can make a mistake. I picked the wrong two trials for the iodide. So when you look at this, it's a pretty basic rate law problem, but for some reason, I don't know, maybe I was jamming too hard to my music or something, and I picked for the iodide trials 2 and 3, but when you see, that's not the two trials to pick because um, the OCL actually changes too, and so that we can't pick those two trials. So I'm going to go back and redo that. Now, for the OCL, it's really simple. I'm doing trial 1 and 2. That doubles, and then we see that the rate doubles as well. So my rate is going to be K OCL. And then the two trials that you want to pick for the iodide are you want to pick this one and that one because you want to pick this one and this one because the OCL stays the same. So I think before I had the iodide as a 0 order, but now it shows that it is a first order because when we double the iodide, the rate doubles as well. So overall, that's a second order reaction. It is first order with regards to the OCL, first order with regards to the iodide. And then the K is going to be 1 over seconds times 1 molarity because we have 2 molarities, we want to cross out 1. So in order to figure out the rate of formation when they're both 3.4, I need to figure out the value of K. I'm just going to go and put K and then plug in the values for the first trial. So you see me do that right there. Just plug that in, and then basically divide both sides by 1.7 times 10 to the negative 3. Now, I made my mistake somewhere else, but if somebody else was going to make a mistake, you're probably going to make it on the math. I'm definitely getting my calculator for this one. And so 1.75 times 10 caret 4, okay? Get that in there, that's 17,500 divided by 0.0017, whoops, divided by 0.0017. Oh, that's a huge number. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 6.06 times 10 to the ninth. And that seems like a big number, but I think that's going to be okay. And that's just going to be 1 over seconds times molarity to cross off the 1 molarity. So I'm just going to go ahead and plug that number in and see if I get my answer for the first trial. So 0.0017 times 0.0017 times 6.06 times 10 caret 9. Yeah. So yeah, even though it's a big number, what that means is that reaction just goes really quickly, and mostly till it uses up all the reactants, and so that reaction really wants to happen. And so, once I've done that work and I've found that K, I can just go ahead and take my rate law. Rate equals K OCL I negative, plug in 6.06 times 10 to the 9th, 1 over seconds times molarity, and then it is going to be 0.0034, 0.0034. I don't know why I'm making them into decimals today. I just feel like it. So 6.06 times 10 caret 9 times 0.0034 times. And so when we double them both, I get 7 times 10 to the 4th, which, if we look at our other rates, here and here, that's pretty much what we should expect.